All right, let's dive in. Today, we're going deep into quantum robotics.
Sounds exciting.
You bet. We got some fascinating articles from JohnFruland.net and the Quantum Insider about this field that's, well, it's promising to completely change the game in industries like manufacturing, healthcare, you name it.
Yeah, I mean, it's like the merging of two of the most cutting-edge fields out there.
Right. Quantum computing and robotics. It's mind-blowing. So our mission today is to really break down, what is quantum robotics? Why is everyone making such a fuss about it? And what are the hurdles and the amazing opportunities ahead?
I think one of the things that really captures people's imagination is this idea of Qubots.
Qubots. Okay, that sounds straight out of science fiction.
Well, in a way it is. They're robots, but with a quantum twist. Think about it. Regular robots, they use bits, right? Zeros and ones.
Like a light switch, on or off.
Exactly. But Qubots, they use these things called qubits. And thanks to this mind-boggling concept called superposition, a qubit can be both 0 and 1 at the same time.
Wait, so it's not just on or off. It's like both. How is that even possible?
It's like imagine a coin spinning in the air before it lands. It's not heads or tails until it settles. That's kind of like superposition.
Okay, I think I'm starting to get it.
So that means Qubots, they can process information in a totally different way than your everyday robots.
And that gives them a huge advantage.
A massive advantage. They can handle problems that would, honestly, make a regular robot's head spin.
And then there's this whole other layer of crazy with entanglement, right?
Yeah, entanglement is wild. It's like you have two of those spinning coins, but they're linked. No matter how far apart they are, if one lands on heads, the other instantly lands on tails.
That's spooky.
Right. And this spooky action at a distance is what could allow robots to communicate and coordinate their actions in ways we haven't even begun to imagine.
So what kind of real-world, tangible benefits are we talking about here? Give me an example.
Navigation is a huge one. Imagine self-driving cars, but way smarter. Using quantum algorithms, they could analyze tons of traffic data all in real time, figuring out the absolute best routes to avoid all the jams.
No more rush hour nightmares. Sign me up for that. What else?
Multi-robot coordination is another fascinating area. Think search and rescue after an earthquake. You've got a whole swarm of drones equipped with quantum sensors, all linked through entanglement.
They'd be like a super organized team, right?
Exactly. They could map the disaster zone, find survivors, and coordinate the delivery of aid with incredible precision and speed, way faster than anything we have now, all thanks to entanglement.
Okay, it's clear that Qubots could be a game changer. But how far along are we, really? Are we just playing with theories here, or is there some actual progress being made?
The research is happening on two main fronts, actually.
Yeah.
One is using quantum principles to, supercharge the robots we already have.
A quantum upgrade for our old bots. Interesting.
Yeah, like researchers at MIT are developing quantum algorithms to make robots much better at learning and adapting to new environments. And then there's the more ambitious stuff building robots with actual integrated quantum systems.
Whoa, hold on. Built-in quantum processors.
Yeah, that's what researchers at the University of Bristol are working on. These robots would be able to handle super complex calculations and make decisions on the fly.
Okay, now that is straight out of a sci-fi movie. But hold on. If this is all so groundbreaking, why don't we see Qubots everywhere already? What's the catch?
Well, the catch is that building these quantum systems is really, really tough. We've got some major hurdles to overcome.
So what's standing in the way of this quantum robot revolution?
Well, for one thing, hardware. Building a quantum computer that's powerful enough and stable enough to run a real-world robot is still a massive undertaking.
The building blocks just aren't quite there yet.
Right. And then there's the software. We need to develop software specifically for these quantum computers to really unlock their full potential.
So it's like having a super fast car, but no one knows how to drive it.
Exactly. We need that quantum software to make these robots work. And another hurdle is integration. Figuring out how to connect these quantum systems with the regular computers and networks we already have, that's complex.
Like trying to merge two totally different languages.
Yeah, something like that. And, of course, we can't forget about security. All these interconnected robots, all this data flowing around. It's like a hacker's dream come true.
Yeah.
Definitely. So as quantum robots become part of these big networks, think smart cities, healthcare systems, all that protecting them from cyber attacks becomes really, really crucial.
Okay, so there are definitely some challenges ahead, but let's switch gears for a second. What about the rewards? What kind of impact could this have on the world?
The potential is, honestly, mind-blowing. We're talking about revolutionizing industries like manufacturing, healthcare, logistics, you name it.
Let's start with manufacturing. How could Qubots change the way we make things?
Imagine a factory where the robots aren't just mindlessly following orders, but they're actually learning, adapting, optimizing things in real time.
So less like mindless machines and more like problem-solving partners.
Exactly. And because they can process information so much faster, you could speed up production times, have way fewer errors, and even create more personalized products.
Okay, I'm sold on that. What about healthcare? I imagine that's where things get really interesting.
Yeah, healthcare is ripe for disruption. Actually, you don't even have to imagine it. Researchers at XYZ University are already using quantum algorithms to control robotic arms for eye surgery.
Whoa, so robots doing surgery, is that even safe?
Well, they're achieving a level of precision that's just not humanly possible.
Wow. So we're talking about faster recoveries, fewer complications, maybe even cures for diseases we thought were incurable.
It's all on the table. And then there's logistics.
Yeah.
That's another field that could be completely transformed. The Quantum Insider article, it suggests that quantum robotics could make supply chains way more efficient, resilient, ready to adapt to anything.
So no more shipping delays, no more wasted resources. It's like having a team of super efficient robots managing the entire flow of goods around the world.
Exactly. And it's not just about efficiency. Quantum robotics could also be crucial in disaster relief. Imagine a swarm of drones with quantum sensors. They could assess damage after a hurricane, locate survivors, deliver aid, all while coordinating perfectly through entanglement.
In a situation like that where every second counts, that could be the difference between life and death.
Absolutely is powerful stuff.
Okay, so we've talked about the incredible potential and gotten a glimpse of the research that's already happening. But those challenges we talked about earlier, I think it's worth digging a little deeper there.
You're right, those challenges are real and they're significant.
So break it down for us. What are the biggest hurdles in the way of this quantum robot revolution?
Both articles really emphasize the need for more robust and efficient quantum hardware. Right now, building a quantum computer that's powerful and stable enough, it's a huge, huge task.
It's like trying to build a skyscraper out of, like, playing cards. The materials just aren't strong enough yet.
That's a good way to put it. And even if we solve that hardware problem, there's still the software issue. We need to develop software that's specifically designed to work with these quantum computers.
Like having a fancy sports car, but no one knows how to drive stick shift.
Exactly. We need the right skills and knowledge to make this work.
Yeah.
And then there's the integration challenge. How do we connect these quantum robots to all the systems we already have? It's not a simple plug-and-play situation.
Right. It's like trying to get two completely different species to communicate.
Yeah, something like that. We need to develop new ways for them to talk to each other. And of course, there's security. All these interconnected robots, all this data flowing around. We can't forget about that.
Right.
Absolutely. Protecting these systems from hackers and cyber attacks is absolutely crucial.
So it sounds like we've got a lot of work to do.
It's a long road, but the potential is so great that it's worth the effort. And we're already seeing breakthroughs that are paving the way for a truly incredible future.
Okay, so we've covered a lot of ground in this first part of our deep dive. We've explored what makes Qubots so unique, talked about the amazing advantages they could offer, and even seen some of the real-world research that's already underway. We've also taken a hard look at the challenges that lie ahead.
From the hardware and software to the integration and security, there's a lot to tackle.
But in the next part of our deep dive, we're going to explore the even bigger implications of this technology. We'll talk about the potential impact of quantum robotics on society, the economy, even our understanding of what it means to be human.
It's going to get really interesting. So welcome back. It's great to dive back into this with you. Where should we pick up?
Well, in the last part, we touched on logistics and, how Qubots could really shake things up in that whole world of supply chains. I think it would be great to dig into that a bit more.
Yeah, right on. Logistics is definitely ripe for disruption. Like, imagine a whole network of, quantum-enhanced robots coordinating the movement of goods all over the globe.
It's a mind-boggling concept.
It is. And these robots, using those amazing quantum algorithms we were talking about, they could analyze, constantly changing conditions. They could really adapt.
So instead of just sticking to these fixed routes and schedules, they could make decisions in real time based on traffic, weather, maybe even sudden changes in demand.
Exactly. Optimize those delivery routes. Predict problems before they even pop up, and just make sure that everything is flowing smoothly.
No more supply chain bottlenecks. No more waiting weeks for your online order to finally arrive.
Right. And it's not just about efficiency either. Think about disaster relief. Quantum robotics could be a game changer there. Like, you have a natural disaster, a hurricane, an earthquake, and you deploy a swarm of drones.
Okay, I'm picturing it.
Each drone has quantum sensors, the ability to communicate instantly, through entanglement, and they're sent into the disaster zone. They could assess the damage, locate survivors, maybe even deliver emergency supplies, and they could do it all incredibly fast, with amazing precision, all coordinated perfectly.
So instead of waiting for, human rescue teams to make their way through dangerous areas,
Hmm.
these Qubots could provide immediate help.
Exactly. I mean, we're talking about potentially saving countless lives.
This is really powerful stuff.
It is. The ability to, respond so quickly in these emergency situations is just one example of the impact quantum robotics could have.
Okay, I'm seeing how this could be a real force for good. But, we talked earlier about some of the challenges. Let's circle back to that.
Mhm.
Where are we at with building the actual hardware and software to make all of this happen?
Yeah, on the hardware side, building a quantum computer that's stable enough, powerful enough, it's still a massive hurdle. It's a very complex process. And even tiny little disturbances can mess things up.
So it's not just building it's building it so that it can work reliably in the real world, where things aren't always, perfectly controlled.
Yeah, exactly. And then even if we get the hardware right, there's the software. We need to develop software that's specifically for quantum computers to really harness their capabilities.
Like, it's not enough to just have the instrument. You need someone who knows how to play it, right?
That's a great way to put it.
Right.
We need those skilled quantum programmers who can, create the algorithms that'll let these Qubots do all the amazing things we've been talking about.
And what about connecting these quantum systems with all the other technology we have? I mean, that can't be easy.
It's a huge challenge. Integrating quantum computers with our regular computing systems, it's a major, major undertaking. We have to, create new ways for them to talk to each other.
And of course, there's security. All these interconnected robots, all this data flying around, it seems like it would be a hacker's paradise.
It's a valid concern. As we start to see these quantum robots integrated into important infrastructure, protecting them from cyber attacks becomes, absolutely essential. We have to be really proactive on the cybersecurity front.
So it sounds like we've got a lot of work to do, both on the technical side and in thinking about the bigger implications of all of this.
Definitely. It's a long road, but it's an exciting one. And I think the potential benefits are so big that it's definitely worth the effort.
So we've talked about the potential of quantum robotics, we've talked about the hurdles, but now I'm curious about the really big picture. How could this change the world? And what ethical questions should we be thinking about as we move forward?
That's a crucial question. And it's one that we'll really dive into in the next part of our deep dive. It's going to be a fascinating conversation. All right, welcome back to the deep dive. So we've explored this incredible potential of quantum robotics, self-driving cars that never get lost, surgical robots with superhuman precision. But now I think it's time to really grapple with the bigger questions here. What does the rise of these quantum robots really mean for humanity?
It's a question that, it takes us beyond the nuts and bolts, the circuits and algorithms, into some pretty deep philosophical, ethical territory. As these machines get smarter, more independent, that line between tool and teammate starts to get blurry.
Yeah, and earlier we were talking about, how Qubots could totally change the workforce, taking on tasks that humans are doing right now. That brings up some pretty big questions about the future of jobs, right?
For sure. One of the articles you shared, it actually mentioned a study that predicted that, within the next decade, automation could displace millions of jobs. And it's not just, factory workers being replaced by robots on an assembly line.
Yeah, it's white collar jobs too. It is. Even creative professions could be impacted.
So it's not just robots taking over manual labor. It's about them potentially doing things that require thinking, problem solving, even creativity better than humans can.
Yeah, that's the challenge we're facing, and it makes us have some pretty fundamental questions like what is the value of human work, of human labor when machines can do so much, and how do we even prepare for a future where certain jobs might just disappear?
These are questions that, societies have grappled with throughout history whenever new technologies come along. But it feels like the pace of change now is just so much faster and the stakes are higher than ever.
It's true. And it's not just about jobs either. As these quantum robots become more integrated into our lives, we have to think about the ethics of it all. We're talking about machines making decisions that could have a huge impact on people's lives.
The example that always comes to mind for me is self-driving cars. If you have a quantum-powered car and it has to make a split-second decision to avoid an accident, how does it choose between, protecting the passengers and maybe harming someone else?
Yeah, that's a classic ethical dilemma, right?
Yeah.
And it gets even trickier when you factor in the speed and the complexity of quantum computing. I mean, who is ultimately responsible for programming those ethical guidelines? Is it the engineers, the government, society as a whole?
It feels like we're moving into this uncharted territory where the old rules, the frameworks we used to rely on, they don't apply anymore.
I think you're right, and we need to start thinking about these ethical questions now before the technology gets so advanced that it's just beyond our control.
So what are some of the potential solutions here? How do we make sure that that quantum robotics is developed and used in a way that really benefits humanity, that doesn't harm us?
Well, I think transparency is a big one. We need to make sure that we understand how these robots are making decisions, that there's accountability built in. We have to be able to trace those decisions back to their source to figure out why a certain action was taken.
So we can't just accept these robotic decisions as like a black box. We need to be able to look inside to see the logic.
Exactly. And I think we need to be having some really honest conversations about the risks and the benefits of this technology. We need to get policymakers involved, ethicists, the public. We need to work together to make sure that these tools, which are so powerful, are used responsibly and ethically.
This isn't just a technological revolution, it's a societal one.
I agree. The relationship between humans and machines, it's about to get a whole lot more complicated.
So we've covered so much ground in this deep dive, the incredible potential of quantum robotics, its use in manufacturing and healthcare, the way it could change how we live, how we work. And we've also really dug into the challenges and the ethical considerations. As we wrap this up, I'm feeling a mix of excitement and caution.
I think that's a healthy approach. It is an exciting time seeing the birth of a technology that could completely reshape our world.
Yeah.
But it's also a time to be thoughtful, to be careful, and to really commit to making sure that these tools are used for the good of everyone.
So to our listeners, we ask, what are your thoughts? What excites you about quantum robotics? What worries you? How do you think we should navigate this uncharted territory? Join the conversation, let us know your thoughts, and let's explore the future together. Thanks for joining us on this deep dive. We'll see you next time.